right, here we go. This lesson is on solving exponential equations. How to solve an exponential equation. Well, the first thing you need to know is what is an exponential equation. So, what is the defining characteristic of an exponential equation? If you look on the bottom of page 165, you'll see 4 equations. And if you look at them, what do they all have in common? What is the one thing they all have in common, all 4 equations? They have a variable in the exponent. So that is the distinguishing feature of an exponential equation. And that's really important, that you're able to identify an exponential equation. So what is an exponential equation? It's an equation that has a variable in the exponent. All right? Okay, so the next thing is, how do we solve an exponential equation, now that we know what they are? Well, as a little clue of how to solve an exponential equation, if you look at the top of page 165, you'll see an equation there, or a question to a review question. So you can try that one. I don't know why I didn't put up the lesson today. Interesting. Not quite with it, I guess. All right, so it says simplify 9 to the 2x plus 3 divided by 27 to the 3x minus 1 times 81 to the x minus 1. And the instruction isn't solve. This is not an exponential equation, but it says simplify. So I think what they're trying to show us with this example is that if you are working with exponents, all the laws of exponents are based on what? When the bases are the same and you're multiplying, you can add the exponents. When the bases are the same and you're dividing, blah, 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 blah. You cannot use the law of exponents if the bases are not the same. All right? So when you want to simplify something like this, the key to simplifying it is to understand that you're dealing with exponents, and you cannot use the laws of exponents unless the bases are the same. So what you would do is you would look at 9, 27, and 81 and say, I can change these all to base 3. So change them all to base 3. So 9 is 3 squared, and 27 is 3 cubed, and 81 is 3 to the 4th. So when we simplify this expression, we would approach it by making the bases the same. Power through, so you get 4x plus 6, divided by power through, you get 3 to the power of 9x minus 3. Where's my other one? Time to the power of, it's 81 to the power of x minus 1. And then that's all multiplied by 3 to the power of 4x minus 4. All right, now the bases are all the same. And once the bases are the same, you can use your laws of exponents. When the bases are the same and you're dividing, you leave the base and you subtract the exponents. 4x plus 6 minus 9x minus 3. You can multiply that by 3 to the 4x minus 4. Simplify. Common error for some students would be that they would not put this in bracket, and then of course there's a problem. So 4x plus 6 minus 9x plus 3, you end up with negative 5x plus 9 times 3 to the 4x minus 4, and you use your laws of exponents from grade 9. When the bases are the same and you're multiplying, you leave the base and add the exponents. So we end up with 3 to the power of 9 minus 4 is 5. Negative 5x plus 4x is negative x. Negative x plus 5. Okay, so not to get lost in the simplifying, let's go back and look at this question. This is is an expression that we were asked to simplify, and this expression has exponents. And when we're dealing with exponents, we know that you have to make the bases the same. That's the key to simplifying an expression with exponents. All right, let's go back to what today's lesson is. Today's lesson is how to solve an exponential equation. So we've talked about what an exponential equation looks like, and now let's see if we can solve some. So the first one you see on page 165 is 5 to the power of 2x plus 3 equals 5 to the 7th, power of 7. The instruction is solve. Solve means find the value of x that makes this equation true. Find all the values of x. All right, the first thing you notice is that this is an exponential equation. It's an exponential equation because it has a variable in the exponent. So how are you going to solve an exponential equation? Well, whenever you're dealing with exponents, you want to make the bases the same. The bases are the same, so this is what a very easy exponential equation. Once the bases are the same, you use this little property. If b to the n equals b to the m, then what has to be true? N has to equal m. Does that make sense? If b to the n equals b to the m, then the exponents have to be the same. So this is our little property that we use to solve exponential equations. How are we going to solve exponential equations? Step 1, we're going to make the bases the same. Why? Because when you're dealing with exponents, you can't apply any of the laws if the bases are not the same. So step 1, make the bases the same. Step 2, what would you say? Equate the, when the bases are the same, you can do what? Equate the exponents. So those are your steps. So let's try it. When the bases are the same, 5, 5, you can equate the exponents. So what do you get? 2x plus 3 has to equal 7. Now what do? You solve for x. Subtract 3 from both sides and divide both sides by 2. X is equal to 2. Answer. All right, let's roll along with this. B. What kind of an equation is this? And I'm going to be repetitive because when you solve equations, there are many, many types of equations. And in this course, we will solve exponential equations, we will solve rational equations, log equations, trig equations, to name a few, radical equations, absolute value equations. And so when you're a student, math student, and you're solving equations, you want to be very good at it, all right? You want to be solving equations at close to 100%. It's something you want to master. The first thing to do when you want to master equation solving is be able to identify what kind of equation you have and then apply the right procedure for solving it. All right? This is not a high-level thing. It's not in itself that interesting. What's interesting is the problems you solve using these equations. All right? So I'm going to look at this, and first of all, I'm going to identify, of course, all the ones today are exponential. But another day, these just appear on a test mixed up with all the others, right? So you have to be able to identify them. So why is this exponential? Because it has a variable in the exponent. How do I solve an exponential equation? Step 1, make the bases the same. So change 343 to base 7. When the bases are the same, you can apply the property. If the bases are the same, then do what? Equate the exponents. Answer's 5. C, 3 to the power of 5x minus 1 equals 81 to the power of 3x. Step 1, identify. What kind of equation is this? Exponential. Why? Variable in the exponent. How? Make the bases the same. So you make the bases the same, you need to go to base 3. 81 is 3 to the 4th, and then it's all to the 3x. Simplify, power through, and when the bases are the same, you can equate the exponents. Now, what question is going to come up? Will this method always work? Someone thinking about that? Is this method going to work for every exponential equation? Well, probably will work for today, because that's what we're learning, right? But when won't it work? Yes, if you can't make the bases the same, you're screwed. And you'll need another method. And that will be in this chapter later on, I think. We'll learn. That's when we'll use logarithms. So this chapter, we're studying logarithms, and that's one of the reasons. So next level will be, what are we going to do when we can't make the bases the same? But today, it's just straightforward. Okay, so D, 3 to the power of x equals 27 root 3. I look at this equation. The instruction says solve, and I identify it. It's exponential, and I know very clearly what to do. Make the bases the same. You see the difference in that thought process? Some people look at this equation and say, I don't know what they say, but they don't feel that happy. I look at this equation and I feel happy, because all equation solving is simple. Identify, classify the type, apply the right method. All right? You don't get bogged down in, oh, there's a radical. But you just don't go there. Okay, so now I know what I'm doing. I'm trying to make the bases the same. So I'm going to base 3. Why base 3, you might ask? Because there's a 3 there. So it's very simple stuff. 27 is 3 cubed. Now I'm going to go to base 3. That's 3 to the power of 1/2. That is a little tricky if you didn't take grade 10 and you didn't learn that little conversion, the radical, how to write a radical as a power, but we went over that, right? Yes. Okay. So now on the left side, or the right side, when the bases are the same and you're multiplying, add the exponents, 3 plus 1/2. That's a little tricky. Just kidding. So 6/2 plus 1/2 is 7/2. When the bases are the same, you can equate the exponents, so x is equal to 7/2. Good. All right, next page, class example number 2, page 166. A bacterium triples every 6 days. The number of bacteria n present after x days is given by the formula n is equal to 3 to the power of x over 6. After how many days are there 243 bacteria? So when n is 243, how many days? Well, days are x, right? So if you solve this equation for x, you'll have your answer. What kind of equation is this? It's an exponential equation because it has a variable in the exponent. How do you solve it? Make the bases the same. Go to base 3. So you change 243 to base 3. And it's 3 to the power of what? 5. When the bases are the same, you can equate the exponents and solve this little equation. So x is equal to 30. The answer would be 30 days. And our final example, oh no, we have 2 more, is 27 to the x minus 2 equals 1 over 81 to the power of x plus 3. Again, classify exponential. How do you solve it? Make the bases the same. What base should I go to? 3. Good. So it's 3 and 3 power through. So it's fairly straightforward up to here. Now what do I have to do? Well, I have to write this in a different way. As a power of 3. That's right. Right? 1 over b to the n equals b to the negative n. Right? I want to write this power. So it's negative 4x minus 12. When the bases are the same, I can equate the exponents. Solve for x. I'm going to add 6 to both sides and add 4x to both sides. So x is equal to negative 6/7. Excuse me. All right. The last question here, 125 divided by 216, all to the power of negative x over 4 equals 6/5 to the power of 3x minus 3. So again, I would classify whenever I'm asked to solve an equation, I classify it. This is exponential because of the variable. Next step, make the bases the same. Clue, 6 and 5. 6/5 is the base over here. That's a multiple of 5. That's a multiple of 6 probably. Check it out. 125 is 5 cubed. 216 is probably 6 cubed. Okay, so now we want to rewrite this as a power of 6/5. So maybe the first thing I would do is take the reciprocal of this fraction. Remember this little law that we had? A fraction to a negative power, take the reciprocal to the positive power. So I'm going to use that and say that's 216 over 125 all to the x over 4. All right, now I'm going to rewrite this as a power of 6/5. So 216 is 6 cubed, 125 is 5 cubed. So all of that cubed, 6/5 cubed is this. And then it's all to the power of x over 4. Power through. So I multiplied the exponents. And now when the bases are the same, you can equate the exponents. Now you're just solving this simple equation. Multiply both sides by 4. And subtract 3x from both sides. Add 12 to both sides. Divide both sides by 9. So x is equal to 4/3. All right, so what's this lesson about today? It's how to solve a simple exponential equation. What's an exponential equation? Anytime you have a variable in the exponent, how do you solve it? Make the bases the same. Very simple, right? Just need practice at it to be very good. All right, so you guys can do this assignment. Now what do? Click this or this? This one?
Yeah.